Okay, functions we've definitely dealt with. So we know what functions are. So functions are things like f of x equals 2x minus 7, or g of x equals x squared minus 9. Like we know what functions are. So we could find f of 3 or f of a plus 7 if we want to get fancy. So we've done functions. Operations, I guess that's maybe a fancy word, but you know what operations are. You may not know this is what they're called. Operations are just the add, subtract, multiply, and divide. So a lot of today you kind of already know because you know how to add, subtract, multiply, and divide. You know about functions. Today we're just kind of put those two ideas together. But there is a little bit of notation that throws people off. So let's make sure we understand what's being asked when we see certain things. F plus g of x. I guess let's first, like how we say that is f plus g of x. And I guess the of x is the important part. The thing in parentheses is what goes in. You don't add f and g and then multiply by x. You add f and g and then plug in whatever is in parentheses. So another way to say this is it's just f of x plus g of x. In fact, why don't we trying to think, do I want to do all the operations or do we want to do an example as we go? Let's go ahead and do the example here. So f of x plus g of x. F of x is 2x minus 9. G of x is x squared minus 9. So if I add those together, and I'm even going to put them in the right order, so x squared plus 2x minus 16. All I did was add f and g. Do not multiply by x. That's what throws people off. They're like, ooh, I'll add f and g and then I'll multiply by x. But this is not multiply. This tells you what the input is. All right, f minus g of x. Well, same type thing here. F minus g of x. So you're not going to subtract and then multiply by x. You're just going to subtract f of x minus g of x. So let's plug in for f of x, 2x minus 7, minus, and then here's where some people are going to make a mistake. If they write it like that, what I wrote is not quite right. I've got f of x minus g of x. Do you know what's not right about that?
The 9 to make it positive.
Yeah, because I need to subtract all of g of x. I'm going to put it in parentheses, which will have the effect of making it positive. So 2x minus 7 minus x squared plus 9. So negative x squared plus 2x plus 2. Right? F times g of x. Same thing. Multiply f and g, plug in x. Don't multiply f and g and then multiply by x. That parentheses x is telling you what the input is. F times g of x. So it's f of x times g of x. Ooh, get the FOIL here. Or distribute, however you want to phrase it. So I'm going to, I think FOIL. So I'm going to do the first 2x times x squared. That would be 2x cubed. Then the outside, 2x times negative 9 is minus 18x. And then the inside, minus 7x squared. And then the last, plus 63. So the foiling step you did a bunch in Algebra 1, so that should be okay. If it bugs you that they're a little out of order, you could rewrite them in order, but you don't have to, meaning the power's decreasing. So it's fine as is, but it does look a little funny with the x squared and the x. It's fine. So that's f times g. Again, I'm not multiplying by x, I'm multiplying f and g. So that's what I've got. And what's left? Division. F divided by g of x. F divided by g of x. Not f divided by g times x. That parentheses there means that's our input. So let's see. F is 2x minus 7. G is x squared minus 9. Get my ball ready to throw at somebody if I need to. Can I reduce the 2x and the x squared? No. Good. No one is going to be assaulted by me today. Good. Do not reduce those. Why can't I reduce those? I mean, 2x over x squared, why can't I reduce an x? I heard mumbling. I hope it was all correct. If we're being added or subtracted, I can't. Those aren't eligible to be canceled. So, put the ball away for now. Everyone is safe. So there's nothing more I can do with this. So this is kind of weird that division is usually the hardest of the operations, but today it's frequently the easiest because you write it, and then if there's nothing more you can do, then you're done. Okay, let's talk about domain. I'm not going to do range today because range would be really hard. We're just going to worry about domain. Which variable goes with domain? X. And so it's the x's. I'm going to phrase it this way. It's sort of the allowed x values. So when we're looking at an equation, it's like we're asking what x values are we allowed to plug in. So I should have said this ahead of time, but I've left enough room for another column over here for domain. Should have made this clear from the get-go to lay your notes out like mine so we could go back and see. So x squared plus 2x minus 16. Is there any reason, is there anything I couldn't plug in there? Like I can plug in 0, I can plug in negatives, I can plug in fractions, I can plug in decimals. Did you get the new packet? Yeah. Okay. So my domain there is all real numbers. Or you could go negative infinity to infinity if you want to be interval notation. I can plug in anything, everything will be fine. Alright, next one down. Negative x squared plus 2x plus 2. Same thing. I can plug in anything I want there. All is good. This third one's got an x cubed, but that's fine. I can still plug in positives, negatives, zeros. Like there's no problem there. I can plug in whatever I like. So if all of these are all real numbers, why are we even talking about this? Well, this last one's not all real numbers. What would be a problem?
0.
Why would 0 be a problem? Like, I can plug in 0 and be okay, but it is related to 0 that's a problem. Like, if I plug in 0, I get 7/9. That's okay. But the issue is definitely related to 0. I can't divide by 0. And so that's sort of that's the only thing for domain that we're worried about today, is that you can't divide by 0. So if something would make your denominator 0, then you can't use it.
Why can't you divide by 0?
So that's
Divided by 0 is just a 0.
No, that's like a really big picture question. So let's back up and think for a minute. 0 divided by 3. So let's say I have $0 in my pocket, and you know what? Let's do 0 divided by 30. We'll make it, because I'm willing to share. I'm willing to share the $0 in my pocket with everyone in the room. Isn't that kind of me? Right? So if I have $0 in my pocket, and I divide it evenly among all 30 of you, how much money do you each get? 0. So 0 divided by 30 is 0. Now let's work the other problem. Let's say I have $30 in my pocket. I'm pretty sure I do not have $30 in my pocket. But let's just say I have $30 in my pocket. And I want to divide it equally among 0 people. Well, how do I do that? Like, I take my $30 and there's no way to divide it equally among 30 people. You can't do that. You can't divide by 0. It just doesn't make sense.
So let's say if there was like 3x at the top.
Sorry, say that again?
Let's say if x was at the top, would 0 be acceptable?
Yes. If we only had x's in the top, we could plug in 0 and be fine. In fact, the shortcut way to remember this, I mean, I hope you understand the principle of what's going on here so that you know 0's in the top is okay, 0's in the bottom is no, but here's the way that some students remember that, okay and no. 0 in the top, we're good, that's okay. 0 in the bottom, that's a no. So okay and no. Okay, so back to this problem. I don't really care about the top. The top can be 0, the top can be anything. But I can't divide by 0, so what values of x would make the bottom 0? And I'm going to factor it to help me find these out. Like 9 would be okay, because 9 squared is 81. 81 minus 9 is not 0, so it's fine. How does this factor? Algebra 1, all stars. X squared minus 9. Remember how that factors? Somebody was awake during Algebra 1. X plus 3 and x minus 3. So that means x can't be negative 3. And x can't be 3. And we could write that in interval notation, but it's just a lot easier to say x can't be 3 or negative 3. Because that would make the bottom 0, we're not allowed to divide by 0, so I can't use 3 or negative 3. So the main issue with domain is just the denominators. Everything else is going to be okay. I didn't mean this one kind of okay, but it kind of means that okay. If there's a denominator, then we have to be worried. Okay, today's assignment, it's block day, so we still got plenty of time. Yeah, we still got 40 minutes left. Today's assignment is this worksheet. I mean, it's from the book, but Miss Green, again, is the hero of the day. So we don't need a book. She's put the book assignment on a worksheet. Now, this isn't hard, but it's a little more than it looks. This first page looks like there's 4 problems on that page. But really, if you read the directions, how many problems? A lot. 16, right? Because for each one, you have to add, subtract, multiply, and divide, and say its domain for each one. Now, you can peek ahead and you can see that the only domain issues are going to be with division, because that's the only one that puts something in the denominator. All the other domains are going to be fine.
Can we do only divisions? Would that be acceptable? Since
If you say it somewhere else that, so you want to say that all of these, so what would you say about the domain for all of those? All real numbers. Because, now I had to cheat and look ahead a little bit, like all of those, none of those have denominators in them, right? If f had a denominator of its own, well then I'd have to be careful. But all of these are polynomials, so all of them are fine for their domain. So yes, that will take out those three. So now all you have to do is f plus g, f minus g, f times g, f divided by g, but then don't forget to say the domain of f divided by g.
wait, so we're doing all of them?
Yep. So why don't you try number one, and then we'll go over those. So do all four of the, or I guess all five, depending on how you count, 4 operations and 1 domain problem. So that just made it 20 problems on this page.